We are in the second part of 8.9, and 8.9, remember, is on page 175 and 76. So there's three types of volcanoes. We've already looked at shield volcanoes, and now we're looking at the second type, which is cinder cones. Cinders, if you've ever had to clean out the fireplace or the wood stove, is the tiny little pieces of wood that are left over after a fire. So if a log that you burn in the fireplace burns completely into white ashes, then there's no cinders. But if you have little specks of black, which is still the charcoal from the wood, that hasn't gone into ash, then they are different. You can have pea sizes, even walnut sizes of different cinders. Okay, so cinder cones means that it's not all pure molten rock that's pouring out of this volcano, but there's also debris. There are cinders, so there's carbon sources that are spewing out of the inside of this volcano. It's not just melted rock only. So if you think of lava, and especially the shield, remember the shield was really, really shallow. It wasn't steep at all. It had a huge base and not a very tall top. Why? Because it was runny. That basaltic lava had very little silica in it. Remember, silica is what you make glass out of. It's what you make sand out of. So it was very thin and runny. And so it ran down and didn't stay thick. Think of pouring water out of a pitcher. Now think of pouring syrup out of a pitcher. Different, completely different. Think of mixing concrete and pouring liquid concrete out of a pitcher. More and more and more thick is called viscosity. It's viscous. It's thick. All right. Well, a cinder cone is going to be thicker than a shield volcano and have other stuff that's ejected. Okay, remember it's called scoria, pea to walnut size fragments of this usually carbon material, cinders. Okay, so on fire, burning as it's spewing out of the volcano, just like pieces of ash, or if you've ever seen a campfire, stuff that floats around floats off the top of the fire and then falls on your shoe and burns your shoe. That idea. Cinder cones, because it's thicker, is going to be higher. So you have steep sides. You also, because it's thicker, will go down all the sides equally. Okay, so think of pouring syrup on pancakes, and if you pour it just right from the middle, all of it around the syrup will drip down the sides on all the sides at the same time. In fact, you try to do it that way. You want it, I don't know, everybody does. Everybody tries to get the syrup to go down the sides equally. So this is what a cinder cone is. You're also going to have, besides just pure lava, liquid rock, you are going to have all of this other material that's going to spew out. So it's chunky, it's gritty, it's a cinder cone. Okay. Now the lava still is made mainly basalt. Remember, basalt is the foundation material of the bottoms of oceans. It's the foundation material of the bottoms of continents. If you keep digging down to the bottom, underneath the rocks, underneath more rocks, the bottom layer of rocks is basalt. And basalt was liquid magma that has spewed out and hardened into rock. And this is the foundation of the crust. So this is what these volcanoes are made out of. All right, with other stuff too. It's reddish brown, usually cinder cones, because that reddish brown is coming from that, not just the melted rock, because melted rock could be any color, grays and blacks, but also the pieces of charred material in it makes it a red-brown color. Okay. There are some cinder cone volcanoes that do have lava, runny, oozy lava, but a lot of times it's just going to spew out all this black kind of gross stuff, like the stuff that would be on the inside of your chimney. Okay. Also, the craters are deep and large. Okay, because these will blow their top. Remember, a shield volcano normally just keeps erupting all the time and oozes out. Well, these guys don't. So you'll have sudden volcanic explosions that create a volcano. Now you can have a volcano grow right out of the flat ground where there's nothing at all. Suddenly now there's a crack. You get the eruption that comes from all the pressure that's deep under the ground releasing all at once, and then you can end up with a cinder cone volcano at the end of a day. Okay, where you had nothing at all, flat as a pancake, middle of Kansas, and if you end up with a hole there going all the way to the magma chamber, you can end up with a volcano right in Omaha. Right, so let's see a little bit more. So cinder cones form quickly, many in less than a month. Okay, if you have a crack that goes all the way to a magma chamber, you can do it, usually in a single eruptive event. So it's not like Kilauea that will erupt for 45 years. Okay, this is usually just on a Thursday about 3 o'clock. It'll just go pow, and then all of a sudden you've got a volcano right now. Okay, you've got a picture here. I believe this is one in, is this Mexico? Let's see. Yeah, so this is a colonial church, and then this is all scoria from a cinder cone volcano that just kind of just pummeled the whole place. Okay, see if I can get this back to big enough. I'm in some trouble. Okay, so here is a picture of a volcano. You can see that this one this is that huge crater at the top. You can see how steep the sides, way steeper than a shield volcano would be. Most of this is gray ash. Okay, so there's that, those cinders. And then this is dormant, so there's no more fire or lava, but you can see where the lava was. The lava ran down this side and then just flowed according to the topography of the land. Okay, so tiny bit of review. They're not very big. They're symmetrical. You've got a picture of a cinder cone volcano on page 177 in your book. Okay, so 1.5 kilometers at its base as opposed to 150 kilometers for a shield volcano. Okay, so 10 times less big, smaller, 10 times smaller than a shield volcano, but steeper. Okay, basaltic scoria, which is more than just the lava, symmetrical, steep sides. Okay, all right. Have a great day.